Okay, now we're going to continue on with section 3.2. Well, I was going to do that in the other video, but kind of had a little mishap there. So in any case, let's get back to looking at correlation coefficient. And remember, this was that R value that our calculator would spit out when we hit out the linear regression on our statistical calculators. And here is the formula that we'll describe below in a second. But remember that when you were in Algebra 2 and in FS, you put some data into each of your lists, and you were trying to find how well this data was fit by a line. And your calculator magically spit out an R value. And the R value was some number that was between, or including, -1 to 1. And if the value spit out a number that was a 1 or a -1, that meant your data was perfectly fit to a line. All the data points lined up exactly on a line. Now, if it was something that was relatively close to 0, that means the data would just kind of scatter all over the place, and you really couldn't predict any type of a linear pattern from the data. So for us, the correlation, I always ask you to give me these two pieces of information. Your correlation will describe the strength of your linear association and the direction of your association. And we're always describing linear associations when we use the little r value, the correlation coefficient. All right, and we'll get to that when we look at an example as well. Now, here's the formula that you were never exposed to previously. And what ends up happening is basically you have two variable statistics. You have an x variable and a y variable, and you'll need to find the mean and the standard deviation of the x's. You want to know where it's centered and how variable it is. You'll also want to take your second variable and find the mean and standard deviation of that list as well. Then what we basically do is we find the z-score. We take each of the data points and take the x-coordinate, subtract the mean away, and divide it by the standard deviation, which means you're finding the z-score of the first data component, and you're finding the z-score of the y component, and then you're multiplying them together. After you find all the product of the z-scores, you'll add them all up, and then divide by 1 less than the number of data items you had, and that means pairs of data items, not individual x's and y's added up. So let's look at our data, and we'll look at how we do this calculation, and you will want your calculator. All right, so I went to my calculator, and I entered into my calculator all of the years from 1987 to 1996, but I only entered in the years after 1900, so 87, 88, 89, etc. And we're going to look at the number of fatalities. So we're going to look at the year as our explanatory variable and the number of fatalities as our dependent or our explanatory variable. And so I put those into my calculator. So again, I went to Stat, Edit, and I have all of my explanatory variables in list 1, and I have the fatalities in list 2. Now, the next thing I want to do is I want to basically take each one of my data points. So this is how we'll calculate our R, and then we'll look at how we put this into a calculator to help us do this a little more efficiently. And after I entered all the data in the calculator, I want to find what the mean of the x's is and the standard deviation. So I have all of the data into list 1 for my x's, and I have the fatalities in list 2. So one thing I can do is hit Stat, Calculate, and if I go down to 2 variable statistics, it will actually use list 1 and list 2 if I don't follow with any other typing, and it will find the mean of the list 1 as the x, and it will find the mean of the list 2 as my y variable. So we know that the mean of the x's is 91.5, or for the years, and then the standard deviation, which we'll use the sample standard deviation, as about 3.03, 3.0278, or 6. And then if I keep arrowing down, I can see that the mean of the y's is the 34.7, and standard deviation, sample standard deviation again, is 19.47 approximately. So rounding these off to the nearest tenth, or excuse me, nearest hundredth. All right, now, this is what we do, and this is what I would anticipate you writing down to show me. So what we need is we need to find what the z value is of each of our data points. So my first data point was 1987, and so I take and here's our formula, I take my 87 minus the mean, which is this 91.5, and let me grab my pencil. Well, I got a pen right here, we'll use that. 91.5, and then I divide that by its standard deviation of the x's, and there's the z-score of the x's. And now I need to multiply that by the z-score of the y. And the first y component is 5. So I have 5 minus the mean of the y's is 34.7, and I need to divide it by the standard deviation of the y's. Now I would actually continue to do this with all my points. I'll put a second one down here. My second data point has the x-coordinate being 88, minus the mean, which is 91.5, and then divided by the standard deviation, which is approximately 3.03. And then the corresponding y component for that is 20, so 20 minus 19.47 divided by the standard deviation. Oops, I'm sorry, that should be 34.7. Looked at the wrong number. Divided by the standard deviation, which should be 19.47. So I have, this is the z-score of the x component. This is the z-score of its corresponding y component, and I really would continue to add these up with all the terms until I get to the last one. And the last one would end up having the year would be 96 minus the mean divided by the standard deviation. There's the z-score for the x component. And then we need to get the z-score for the corresponding y. And if I look at my list here, it looks like 55 is the number of fatalities for the last one. 55 minus the mean, I'll get that right mean this time, and divided by the standard deviation. Okay, so that's what this formula means. Find the z-score of the first x component, multiply it by the z-score of its corresponding y. You'll have a whole series of products that you'll be, the sigma means add them up. And once I get this all added up, I will divide that or multiply it by 1 over, and the number of data points was 10, so I would divide it by 9. Okay, now this is pretty cumbersome to do, to calculate all these out. And we could, find this calculation, write it down, or find this product, or write it down and store and so on, but we're going to utilize our calculator. So let's look at how do we do that on our calculator. Okay, so I have all the data in here as list 1 and list 2. Now what we're going to do is we're going to go over to list 3. And I'm going to find, as you can see I've written down here, we're going to have list 3, and we got to get up into this icon. I want it to find the z-score of my x list. So I take left parenthesis, and I take this first data point, which is list 1, minus the mean, and I know the mean of the x's was 91.5. And then divide it by the standard deviation of x. Now, I can either type in this 3.03, which is a rounded off version of the standard deviation, or I can do this. Variables, on this button right here, variables, statistics, and notice I have some statistics that are shown here. And after I did my 2 variable statistics, it remembers that standard deviation of x. And then I hit enter. Now, likewise, I need to find a z-score of all of the y components. So I'm going to go over to list 4. I'm up in this list 4 icon, and I want to take the y-coordinate and subtract the mean away from it, and then divide it by the standard deviation of the y's to find the z-scores of all of that whole list. But I want to have it do all of them at once. So I have my left parenthesis, and I have list 2 minus the mean of the y values, which I know that that's 34.7, and it's a nice decimal number that I didn't have to round, so I'm just going to write down the 34.7, or type down the 34.7, And now I'm going to divide it by the standard deviation of y. Now I know that this value that I had, 19.47, was a rounded off value, and I could use that. But I'm going to go back and utilize my variables, statistics, and I'm going to go down to the standard deviation of y, and that will allow me to find that entire list all at one time. Now